This is Hailey Harrell reporting live from Vero Beach, Florida. Today is December 31st, 2016, the last day of 2016. It's a chilly day with a high of 75 and a low of 47. After yesterday's cold front, temperatures should continue to rise throughout the week. And speaking of rising temperatures, today we will be talking about the effects of temperature on chemical equilibrium. This is today's daily science lesson. To keep equilibrium, temperature must be constant. In other words, both sides of a reaction must be in balance. If heat is given to a system, it wants to decrease its temperature to even out the balance. During this, equilibrium shifts to the left or right in order to maintain the balance. If the forward reaction is endothermic, an increase in temperature causes the system to shift to the forward direction. If the forward reaction is exothermic, an increase in temperature causes the system to shift in the reverse direction. You got all that? Now it's time to get to the specifics. An increase in temperature above the activation energy will cause the reaction rate to increase, thus lowering the reactant concentration and increasing the product concentration. This changes the equilibrium of the reaction. If the temperature of the reaction is below the activation energy, the reaction will reverse. The opposite effects will be observed for a decrease in temperature. That's all for today, folks. Now to you, Jackie. You got all that? You got all that? You got all that? You got all that?
Good afternoon. This is Jackie Lindstrom reporting live from the most reliable news channel in the nation. Today I'm joining you from Ann Arbor, Michigan, a college town home of the Wolverines. The University of Michigan men's hockey team took the win last night 2-0, while the women's hockey team got stuck in equilibrium. Tied, until they pulled ahead 3-2 in the third quarter. Speaking of the University of Michigan, a group of college students have been studying the effect concentration has on equilibrium in a chemical reaction. The recent breakthrough has caught the attention of researchers all over the world. Let's take a look at what they have to show us. We're back on the scene. What can you tell us about your recent discoveries?
Hi, so we've been studying how concentration affects equilibrium, and we've proven that increased concentration of the reactants makes it so that there's an increased concentration of products as well. So in other words, it shifts the reaction in a forward direction. This is due to the higher likelihood of reactions with increased concentrations.
Okay, so this changes the rate of equilibrium.
Yes. On the flip side, reducing the concentration of a reactant will decrease the yield of the product.
Let me just sum this up for you folks. Increased concentration of reactants and decreased concentration of products will shift the equation forward, while decreased concentration of reactants and increased concentration of products shifts the equation in the reverse direction. Thanks for watching.
Thank you, Jackie. And now for your national news report. A group of scientists have begun a new study on the effects of pressure and stress on high school students from the new higher expectations. It has found that while this high pressure can cause the students to produce more, their reaction to learning has lessened due to exhaustion. We interviewed one young student, Sarah LeClaire, a junior, on her experience in high school.
Hi, Sierra. Thanks for having me on the show. I have so much homework and have done so much school this year, but I'm so tired from only getting 4 hours of sleep every night that I find it really hard to react to the wonderful learning experience provided to me in school.
Thank you, Sarah. This study has been linked to the effects of pressure on equilibrium. You see, when the pressure of a homogeneous gaseous system is increased, the rate of reaction is also increased. This is because pressure and volume are inversely proportional, so a decrease in volume would cause molecules to react quicker while increasing the pressure. Thus, more product is formed than reactants remaining when the reaction is in equilibrium. So, more pressure means more product and less reactants. Just like the high school students. The opposite occurs when the pressure decreases, so less product forms and more reactant remains in equilibrium. Additionally, an increase in pressure causes the system to shift in the direction of fewer gas molecules, A decrease in pressure causes the system to shift in the direction of more gas molecules, and if the number of particles on each side of the reaction is equal, then a change in pressure has no effect. That's all for tonight, folks. Have a wonderful week, and get some sleep tonight.
To keep it equilibrium. Are you serious? I'm balancing this at a spoon.